Hey guys, today we're going to be talking about Java Arithmetic, and we're also going to be using Visual Studio Code IDE today just to show that all the stuff that we're talking about doesn't only work in Eclipse. So let's start off by making a new Java project. We're going to click Ctrl-Shift-P to open this menu, and you're going to find Java Create Java Project. Now note that if you haven't downloaded the right dependencies, you won't be able to code in Java. There's a separate process that you have to do to code in Java with Visual Studio Code. But once that's done, we can start by choosing a location for our new project. And we're going to name it New YouTube Project. Okay, so this new browser is our new project. So let's go ahead and click into this. We're going to find the source code folder. And inside the source code folder, we'll go to the app package and we'll just add a new Java file here. So we'll click new file and we'll say arithmetic.java. Okay, so here we have our new file. So let's start by making our quick class declaration. Oops, over here. So we're doing class arithmetic and let's say public static void main string args. Okay, so if you notice, we'll have this red underline here. And that's because we have our arithmetic Java program in the app package. And usually in Eclipse, you don't have to do anything because we're usually in the default package. But since we're in the app package, the very top line of our program must specify the package that we're in. So all we have to say is package app, app being the name of this folder. So now that we have that taken care of, let's start talking about arithmetic. So first we'll talk about integer arithmetic. So to represent that, we'll make two variables, a and b. Int a is equal to 6, and int b is equal to 7, say. So there's going to be 1, 2, 3, 4, 5 different operators we're going to talk about. It's the plus, the minus, the times, the divide, and finally the modulus symbol. So let's talk about adding, subtracting, multiplying, and dividing first. So let's just print out these operations. These operators are what we can use with operands to produce values that are desired. So we can say a plus b, and that'll add the values from a and b together. So if you print this out by clicking run up here, we'll see at the bottom that it prints out 13 because 6 plus 7 is 13. The same thing applies for subtraction and multiplication. We do a minus b, and we'll also print out at the same time a times b. So a minus b, 6 minus 7, we should get -1 from this statement, and a times b, 6 times 7, we should get 42 from this statement. So let's run this to make sure. Okay, we got -1 and 42, so that's good. So now let's talk about integer division, because integer division is a separate, might be an issue. You could call it an issue, but it's just a separate little quirk in Java that involves division with integers on both sides of the operator. That means that both operands are integers. So let's say we do a divided by b. Now you'd expect to get a decimal, right? But if you run this, we see that Java outputs 0. So why is this? Well, in Java, in integer division, that means that both sides of the division symbol are integers. The result of this statement, the value of a divided by b, is truncated. The decimal is truncated. So basically, if it resulted in 3.14, if you were to divide it in a calculator, it would truncate the 0.14 and it would just be 3. So as you can see here, a divided by b would be 0 point something, and Java would truncate that decimal, so now it's just 0 over here. So in a similar way, we can also say b divided by a. So b goes into a one time, so it'll be 1 point something, the actual value. But that point something will be truncated by Java. So if you just print out b divided by a, you'll see that we'll get 1. And here it is right here. So that's the one little quirk about division in Java. So let's move on to the next and final operator that we're going to discuss today, and that is a mod sign. Mod is also synonymous with modulus. So let's print out a mod b. So what does this little percent sign mean, which represents mod? It means that you divide a by b and you find the remainder and you print that out. That's returned by this. So you divide a into b and the remainder is what's printed out by the statement. So if you divide 6 into 7, that's 0 with the remainder of 6. So this should print out 6 if we run this. And here you can see it printed out 6. If we instead do b mod a, 7 goes into 6 one time with the remainder of 1. So the remainder when dividing b by a is 1. So if we print out that statement, we'll get a 1 over here. So that's all about integer arithmetic. So now let's discuss double arithmetic. Let's comment out this code so that'll be easier for us. So we're going to make two variables, an x and y, that represent doubles. So double x is equal to 5, and double y is equal to 6. And if you notice, you can put integer values into a double. This integer value gets converted to a double value when you assign it like this. So just because you're putting an int in doesn't mean that integer division applies when using a double variable. As you can see, if we print out x, we won't get 5, but we'll get 5.0. So these values are converted to double. With that out of the way, let's do the rest of the operations again with double. So we'll add x and y, subtract x and y, multiply x and y, divide x and y, and mod x and y. Let's print x plus y, x minus y, and x times y first. And let's print these statements out. Okay, so 5 plus 6 is 11.0, 5 minus 6 is negative 1.0, and 5 times 6 is 30.0. So that all checks out. Let's do division this time and see what we get. We do x over 5, or x over y, and we run this. You can see that we'll get the actual value when dividing x by y, or at least the value that's really close to it. So this is not like integer division because the operands on both sides of the operator are not integers. So if there's at least one double on either side, this will produce the actual result with the whole decimal there. Okay, let's talk about mod now. So we can also print out x mod y, so x percent y. And if we do this, you'll see that 5 goes into 6 0 times with the remainder of 5. So we should get 5.0 if we run this. And here's our 5.0. Similarly, if we do y mod x, 6 goes into 5 one time with the remainder of 1. So if we run this, we should get 1.0. And here you go. So as you can see, I hope you notice that whenever we have a double variable in our arithmetic over here, it produces a double expression, which means it has a decimal value at the end. However, if both of the operands are integers like we did earlier, you'll see that the result is an integer. And so let's quickly talk a little bit about what happens if you use the operators with two different types of operands. So say we multiply a double and an int, and we divide a double and an int. What's going to happen? So let's make some quick variables. Actually, we have all the variables declared. So let's say a, which is an int, times x, which is a double, and see what that prints out. So a is 6 and x is 5. So if we run this, let's comment out this code right here. If we run this, you'll see that we'll get 30.0. So if at least one of the operands, which is one of the terms on either side of the operator, is a double, it'll use the more precise data type when computing it. So this will get converted to a double. The int will get converted to a double when it is multiplied by a double. We can also do a over x. And so a was 6 and x was 5. So let's just remove this real quick and run it. So as you can see, we get the exact value. Even though one of the operands was an integer, it took the most precise operand, which is a double, and that is the type of value that is produced over here. So that's it for today, guys. I hope you liked the video and stay tuned for more. Thanks.